Superheat treatment plant, an ISO 9001-2000 company. Superheat treatment plant boasts of more than 2 decades of highly successful performance in the field of commercial heat treatment of ferrous and non-ferrous alloys. Hard work, dedication, and unflinching adherence to quality have made Superheat treatment plant a popular service unit for the engineering industries of all cross sections: cottage, light, medium, and heavy. A team of experienced workmen and technicians, supported by the guidance of a renowned metallurgist, ensures correct cycles of heat treatment and rigid metallurgical control, as well as continued development activities to meet the critical needs of customers. Materials heat treated at superheat plant. As per IS, BS, AISI, DIN, GCS, FNOR and other international specifications. Carbon steels MS, EN1A, EN8, EN9, etc. Alloy steels EN19, EN24, EN31, EN36, EN353, 2GMN, CR5, etc. Tool steels, cold work steels CW1, OHNS, 01, A2, etc. HCHCR steels D2, D3, D6, etc. Hot die steels H11, H12, H13, H21, etc. High speed steels M2, M15, M35, M42, T1, T4, T15, T42, ASP30, ASP60, etc. Shock resisting steels SR2, SR3, SR4, etc. Die block steels DB4, DB5, DB6, etc. Spring steels EN42, EN45, EN47, etc. Valve steels EN52, EN53, EN54, etc. Stainless steels Austenitic stainless steels ASI 304, 310, 316, EN53, etc. Martinistic stainless steels ASI 410, 420, 440A, B, C, EN56, EN57, etc. Precipitation hardening stainless steels 17.4 pH, 17.7 pH, etc. Aluminum alloys commercial duralumin, silumin of various grades. Copper alloys commercial brass, bronze of various grades. Heat treatment processes at superheat plant: stress relieving, annealing, full annealing, process annealing, isothermal annealing, spheroidize annealing, spheroidizing, normalizing, hardening, quench media, water, oil, polymer solution. Stepped quenching, tempering, tempering, tempering. Flame hardening, solution treating, precipitation hardening. Natural or artificial aging, in situ stress relieving with time temperature recorder arrangements. Gas carburizing, optimum combination of high wear resistance and surface hardness with tough core. Control of carbon potential in the process to ensure proper case microstructure free from the carbide network. Case or core refining treatment to achieve fine-grained structure throughout the mass. Improved endurance limit in fatigue. Case depth 0.5 to 3 mm, different ranges using conventional carburizing fluid. 0.1 to 0.5 mm, different ranges using special carbon nitriding fluid. Nitriding, liquid or gas. Improved hardness and wear resistance on steel surface. Hardness achieved is 300 to 350 VPN for carbon steels and 600 to 900 VPN for alloy steels, depending on grades, surface condition of jobs and pre-nitriding heat treatment parameters. For special nitriding steels containing chromium, molybdenum, vanadium, aluminium, etc. as alloying elements, the hardness may exceed 1100 VPN even. Nitriding is a no-quench subcritical heat treatment process. So along with very high skin hardness, this process ensures good dimensional stability also. Nitriding is generally recommended as a finishing operation on tools or components after final grinding or machining. Improved endurance limit in fatigue. Good atmospheric and aqueous corrosion resistance. Improved heat resistance. Surface hardness is retained up to 550 degrees Celsius. Case depth from a few microns to 0.8 mm, different ranges. Applications: automobile components, crankshafts, gears, hot working dies, press molds, plastic molds, HSS cutting tools, gauges, valves, bushes, flanges, shafts, etc. Induction hardening. The process involves progressive heating of the components within suitably designed inductor coils, generating altering current of desired frequency, quick soaking and immediate quenching by pressure jets of water or polymer solution. Quick heat, quick cool. Method ensures very fine surface microstructure. Alternating current through inductor coils generates electromagnetic field, inducing eddy current on the surface area of the job. The skin current produces skin heating only, which excludes the possibility of mass effect in eventual quenching. So induction hardened jobs always achieve more surface hardness than volume hardened jobs, particularly for big masses. In volume hardened jobs, the surface hardness becomes reduced by self-tempering due to evolution of enormous core heating during mechanistic transformation in quenching. Quick processing means minimum time of soaking at the elevated temperature, so no scale is formed on the work surface. Improved endurance limit is fatigue. Case depth up to 15 mm, different ranges. Applications: tractor and automobile components, crankshafts, work rolls, backup rolls, piston rods, axles, shafts, gears, spindles, etc. Cryogenic cold treatment. Cryo -300. Characteristics: Cryo -300 is a deep freeze super cold treatment at -300 Fahrenheit or -184 degrees Celsius. Cryo -300 is a deep freeze super cold treatment at -300 Fahrenheit or -184 degrees Celsius, carried out on various tool dies and plenty of other engineering components. The treatment effects extraordinary improvement in performance. The surface life of tools or components enhances by 100 to 400% by this treatment. Cryo -300 is a one-time surface to coat treatment, and its effects is not removed by repeated regrindings. It works like a coating but lasts after resharpening or remachining. The process causes complete transformation of retained austenite to martensite, ensuring added strength. Cryo -300 produces the most stable microstructure in a metallic component, effecting extreme dimensional stability. No thermal shock is involved in the process. Cryo -300 also causes strengthening of molecular bonds and fine metallurgical structure, effecting enhanced wear resistance, toughness, and durability. Applications: HSS cutting tools, gears, carbide tools, shear blades, piston, knives, gauges, dies, molds, blades, punches, rollers, bearings, and etc. Furnace facilities or temperature ranges. Superheat treatment plant is equipped with a good number of electrically heated coil type or electrode type salt bath furnaces covering various application ranges within 150 degrees Celsius to 1300 degrees Celsius. Capacity of heat treatment is, however, the most in range of 350 to 950 degrees Celsius because of additional availability of a large capacity oil-fired salt bath furnace. Superheat treatment plant also houses a large number of muffle and semi-muffle electrically heated furnaces, both chamber and pit type, to take care of almost all grades of steel and some specific grades of non-ferrous alloys for enormously big size rollers, shafts, etc. Facilities are also available to undertake the heat treatment within tailor-made insulated cage chambers with temperature limit up to 1100 degrees Celsius. Big capacity water, oil, polymer solution tanks provide the eventual quenching facility to meet the proper end hardness value. Recent commissioning of an induction heat treatment plant has provided us with an additional leverage to undertake such jobs on commercial basis. All furnaces, salt baths and thermal chambers are provided with highly sensitive temperature controllers to ensure thermal control within 5 degrees Celsius. Quality control or inspection facilities at superheat plant. Rockwell hardness testers, A, B, C scales. Vickers hardness tester, minimum load 5 kg. Brinell hardness tester. Digital hardness tester, HRA, HRB, HRC, HRD, Vickers and Brinell. Poldy hardness tester. Shore scleroscope, microstructural examinations for specialized jobs. Support industries. Under the same management, Superheat Treatment Plant run two sister concerns which provide support to Superheat Treatment Plant in various fringe activities. Tool Technique Industries. TTI is a self-sufficient unit engaged in the manufacturing of various cutting tools, dies, metal segment saws, work rolls, backup rolls, and many other engineering components. TTI supports us by way of fabricating different jigs, fixtures, furnace shells, insulation cages, etc. We tap their technical resources for our various maintenance activities as well. SAS Engineering. SAS is primarily a sandblasting unit. On specific demand, components heat treated at superheat treatment plant are sandblasted here. Sandblasting makes the components free from dirt, scale and contaminations to give them a real glossy finish. This operation is particularly essential for threaded components or tools and many other jobs which do not demand post-heat treatment, grinding or machining. Being also an independent unit, SAS undertakes many other sandblasting jobs on their own commercial terms. Recent acquisition. Superheat Treatment Plant has commissioned one butt welding machine. This facility will help us additionally serve the tool makers and many component manufacturers for fabrication of their various two-piece construction work items. Troubleshooting. In our constant endeavor to achieve perfection and for rendering better service to our customers, we hold periodic meetings with them to discuss various problems related to our engineering discipline. Failure investigation and its eventual solution always receive serious attention at Superheat Treatment Plant. Our consultation of several metallurgical literatures, we find that the failure of a tool or a component occur due to the following reasons in different combinations. When selection of material is at fault, when material itself is a fault, when tool or component design is at fault, when machine is at fault, when heat treatment is at fault, when grinding is at fault, when service parameters are at fault. Long experience in our field of activities duly justifies these 7 reasons. In the light of above, we share our experience with the customers, and in return, we gather knowledge, ideas from them for onward improvements in our performance. Objectives of superheat treatment plant at a glance: quality, prompt service, timely delivery, courteous relationship with customers, frequent interaction with customers for mutual growth, free consultancy for better quality management.